Hello, everybody. Good morning, good afternoon, good evening, depending on whatever time zone you're joining us from. I learned to greet you this way because I never know where you are tuning in from. So welcome. Glad you can join us for another episode of DE Webcast. First, to make sure that you're in the right episode and in the right link, this is an episode called Parametric and Parallel Simulation in the Cloud for Automotive, Aerospace, and Manufacturing. And this episode is sponsored by SimScale. Now, before we begin, I want to give you a few tips so that you can get the best possible experience. By the way, if you have questions about the topic or questions for our speaker, you are welcome to submit them into the Q&A box at any time. We'll take your questions live, and then we'll address as many of them as time permits. The ones that we cannot address live, I promise you, we work with our presenter to get you a written response. You can also download a PDF copy of today's slides and check out the resources related to the topic, to the resource list on the left side of your window. If you are experiencing any technical problems, please visit our webcast help guide by clicking on the help question mark icon at the bottom of the screen. If the slides doesn't seem to be advancing, you might want to try pressing F5 to refresh your browser. That usually solves this kind of problem. Okay, today's topic, what is it? Parametric and parallel simulation is actually one of the ways that allows you to explore a large number of design options effectively simultaneously. And it's usually the method that works best when we do it in the cloud by its very nature, because cloud is scalable and unlimited in a manner of speaking. Let's meet our speaker first. Nolan, welcome. Would you mind saying hello to the audience and tell us who you are and what you do at SimScale, please?
Yeah, thanks, Kenneth. Appreciate the time. I'm a senior application engineer at SimScale. Little background on me. I hold a master's in aerospace engineering from North Carolina State University. I've been fascinated by computational fluid dynamics and all sorts of CAE simulation since my university days, and have made it that type of technology the focus of my career for the most part ever since. So I spent time in everything from NASA to NASCAR, and I'm really excited to speak to you today about how SimScale is disrupting this digital simulation landscape.
Very good, Nolan. So I'm going to let you set up your screen share and everything, and I will turn the floor over to you. So audience, once again, a reminder, if you have questions as you are listening to Nolan's talk, please feel free to jot them down, type them into the Q&A box. We'll start addressing. So Nolan, it's all yours.
Thanks, Ken. So now that the introduction's out of the way, you shall see my presentation, and I'll just jump right into it. And really, before we go any further, I just want to provide a really quick overview of what you're going to see during the time we have today. First, we're going to talk about how SimScale is empowering engineers and designers to utilize this kind of virtual simulation to develop better products faster, and show you some key enabling features in our platform that help accomplish this task. Then I'm going to review some industry examples of projects we have tackled in the aerospace, automotive, and manufacturing industries. And finally, I'm going to quickly walk you through the setup of one of these cases live in my web browser, and then follow that up with some of your Q&A. Before I get into it, a quick introduction to SimScale. SimScale was founded more than 10 years ago with a mission to empower engineers to innovate faster by making high-fidelity engineering simulation technically and economically accessible at any scale. So let me break down more specifically on how we're achieving our mission. We make simulation accessible at any scale. We do that because SimScale is powered by a state-of-the-art cloud, high-performance computing, and web accessibility. We enable engineers to simulate without compromises. We have a wide range of physical models and near limitless computing power that's going to be at your disposal. And we deliver a modern, best-in-class UX and world-class tech support. The platform has streamlined collaborative workflows and is paired with live in-product access to our simulation experts. And as you can see here, we have many thousands and thousands of users worldwide in our platform today. In a few minutes, I'm going to be discussing in detail several of these industry examples across the various industries shown here. But before I do so, I want to first describe for you in more detail some specific features in the SimScale platform that will enable the mass adoption of our technology for product development. So just a bit of a tease there. Here at SimScale, we've identified 5 key factors that have enabled our customers to unlock the potential of physics-based simulation in their process. First and foremost, as we already said from the outset, SimScale is 100% always on cloud native as a solution. What this means for our users is there's no any burden. There's no longer any burden placed on IT departments to manage VPN access or license servers or software updates and rollouts. We take a SaaS approach, so software as a service, that allows users to access the latest version of our platform anywhere they have a web connection and a browser, so no fancy hardware required. Second, you might have noticed I keep referring to SimScale as a platform. This is intentional, as the product is really a launching pad for a broad range of physics capabilities, all contained in a consistent, connected environment. So whether it be the structural FEA analysis, the fluid CFD analysis, or thermal analysis, those can all be accessed in one project, enabling a wider breadth of product understanding and avoiding any kind of development silos. Next, we take a truly modern approach to cloud collaboration and user support. So gone are the days of having to maintain a complicated file structure, terabytes worth of simulation data. And you can forget having to wait on a support ticket or a reseller to respond when you have a problem, and having to jump through all those logistical hurdles to share your simulation. We solve this by basically all project sharing and support is going to be native and integrated right into our platform, similar to what you'd see in a tool like Google Drive or Dropbox. And we have live in-product chat as well. Leveraging the power of the cloud means you do not have to make the compromises on the number or the fidelity of the simulation cases you are going to run, and you don't ever have to think about licensing or license tokens. Design space exploration in both parametric design and model inputs is easily set up, and all cases are ran massively in parallel, so your product is better understood and design cycles are massively shortened. Finally, SimScale is the most cost-effective solution for our feature set on the market. Allow me to elaborate a little bit on what I mean by this. The traditional legacy approach to CAE has typically required customers to make large capital investments in HPC hardware and costly, often fairly confusing software licensing and feature management. The big hidden cost that many don't kind of consider is how much specialized education can be required for some of these tools as well to get up the learning curve in some of these complex and in some cases pretty arcane tools. In SimScale, we have disrupted things by having no hardware for you to buy or maintain or complicated licensing. When you have access to the SimScale platform, you just log in via secure login, and pricing is usage-based. Since SimScale was created from the ground up with the ease of use in mind and includes a world-class support, the costly specialized training is typically unnecessary. And you really don't have to take my word for it. I made a quick little animated GIF here to show you how basically a project can go from project creation to execution in just about, I think, about a minute here. So as you see, we're importing our geometry into the SimScale platform. Excuse me. A static FEA analysis is being set up. Materials are being defined for the particular object. And finally, boundary conditions are applied as needed. In this case, the torque's being applied to the exterior of the motor shaft. and the other end is being fixated. So yeah, in the span of maybe less than a minute here, this is all there is to it, and now the simulation is actually ready to execute on cloud. You can see here within minutes we have a solution to this problem. Okay, so on to the industry examples. As I said before, SimScale is utilized across a very large user base globally, and within that user base we have a very diverse range of industries represented. And so today I just wanted to share a few examples from the key fields of aerospace, heavy manufacturing, and automotive as well. For the aerospace, we've really made great strides in building a solution for quick and accurate simulations of rotating equipment, which includes high-speed pumps. For manufacturing, which is really the broadest sector, we have a lot of examples to choose from, everything from fluids to thermal to structural mechanics. But I've decided to highlight a really interesting industrial oven. And then finally, in the automotive world, we're going to explore how simulation was used to quickly address a fundamental plastic closure design issue, impacting the production of a headlight assembly. The aerospace pump use case, this really demonstrates SimScale's commitment to efficient rotating machinery simulations, which is one of our key application areas. By taking advantage of virtually unlimited high-performance cloud computing and our robust automated meshing, and then finally one of the fastest physics solutions on the market, we're able to obtain rapid and accurate results for both steady state and transient pump performance, which we generated in literally in minutes. As you can see here, the accuracy compared to experimental tests is very closely correlated. And the important physics also, such as cavitation, can be captured in this modeling approach. So in a few minutes, I'll walk through the setup process of this automated pump curve simulation live in the SimScale platform for you. In the industrial manufacturing use case, we almost always center around how to optimize equipment for efficiency or throughput or safety. And historically, these goals were achieved through costly testing or decades of incremental kind of sage knowledge. In the example here, one of our customers in the industrial oven market used SimScale to understand all of the different what-if scenarios for the heat distribution in their one product under various fan scenarios. So as you can see here, within minutes, they're able to quickly visualize the temperature distribution in their product to help improve the performance, uniformity, safety, and even determine things like instrumentation placement as well. Finally, the automotive industry, which is near and dear to my heart. I'm located here in Southeast Michigan, so it's a big part of my world. And we have a really good representation in the SimScale user base from a broad range of applications, everything from aerodynamics to thermal management and structural engineering. In this particular example, there's a clip on an injection molded headlight enclosure, which was failing during assembly for roughly 30% of the units. A rapid redesign was required, and SimScale was called upon to expedite that process with the designers. After quickly assessing 3 different design variations and 3 different material combinations, a viable solution was found to minimize the peak stresses and avoid permanent yielding or breakages, and getting the production smoothly back on track. Okay, so as promised, I'm going to walk now through a live demo of the SimScale platform, and I'll use the water pump scenario as a demonstration problem. So what I'm going to do is just switch tabs here, and you'll note I'm still in my web browser, but now I'm actually logged into my SimScale account, and I'm in what we call our workbench view. So geometry was imported here from Onshape, and I spared us the minute or two of getting the geometry imported. So we're starting at the step where the geometry lives in the platform. And now I can create my simulation. I guess before I do that, we can just observe the geometry a little bit here. We see our pump, impeller internally, and then a simple cylinder to define the rotating region. Our subsonic multi-purpose flow solver is going to be utilized. This is ideal for rotating machinery or flow control devices such as valves. And we see here that the geometry is automatically added in to this simulation that lives in the tree over here. Now I'm going to work top to bottom, and generally we see where SimScale has validation checks, so it has certain information that it needs. If that simulation is properly set up, you should not see any red circles in the tree. So it's a guided workflow. First off is defining our material. Fairly straightforward. We're going to just flow water. Next would be applying the proper boundary conditions. So in this case, we're going to exploit some parametric capabilities in SimScale by actually looking at a range of flow rates rather than just a single value. And I can place as many of these as I'd like in a table. You can also import this in from a simple DSV file to a few. And I'll apply this at the outlet. Then we just simply define an upstream total pressure inlet and no slip walls on all the non-rotating components. Excuse me. Finally, the rotating zone is going to be modeled using a MRF approach. And this is really neat to set up. All we do is have to pick the rotating volume. We can use this button here to make sure it's centered on that cylinder. And we just give a rotational velocity. And that's all we have to do now. We can just go ahead and submit our case to run. We can see here that this experiment, so it was running through the 3 flow rates, runs in minutes. And now this is spinning up on a cloud instance. So I no longer need to actually even keep this tab open. I can exit or close my computer, and I'll actually get an email when the case completes, notifying me that the simulation is completed. Once completed, the kind of information we can extract, here's a run that I did earlier, and I did a few more conditions just to get a little more data points. And this is just one such plot we can get. This is going to be our head rise versus flow rate. So for each of those individual cases, again, in about 10 minutes. We can also look at forces acting on the impeller, and maybe of most interest here will be looking at the power. Now this is a little bit confusing because it's negative on the y-axis, but we can see here that for the higher flows, what our power requirements would be. Furthermore, we can dive into any one of these individual runs at any given flow rate, and we can start to detailed post-process the pump's performance and get a better understanding of our product and maybe the why behind why we're seeing maybe either a beneficial or a drop in performance. So this really is not limited by anything other than your imagination. We have the capability here to create, plane sections. This is all, again, live in my browser. I'm able to move these sections around, update in real time, apply things like velocity vectors, streamlines, look at skin friction on the walls, you name it. There's really no limit here. And then any image or any kind of content we create here, we can actually save as a screenshot that will persist in this project. We can also download that, of course, and include it in reports. We can see that's a screenshot there. And we can animate any transient simulations or any kind of animated content as well. I think the last thing I'll point out before I move away from the SimScale platform is if at any point along the way, when you're in your SimScale project, you can use this live in-product chat here to immediately get support from our desk of experts. And if need be, to help troubleshoot, you can even share viewing privileges of your SimScale project with whoever is supporting it. And that's really unique. So in summary, I want to remind everyone that all of us here at SimScale, we wake up every day with the goal to empower all engineers and designers out there to innovate their products faster and more cost effectively at all scales. Our product and our market approach really embodies this in every way. And we do so by really reducing the total cost of ownership and accessibility to tools like this. And we allow the end user to scale up their scope of what they're analyzing by being both computationally and organizationally scalable. And so with that, I'd like to thank everyone for your time and attention. And I'll open the floor up to questions. But before I do, I just wanted to quickly direct you to a couple links here. If you want to set up a community account and start simulating in the SimScale platform today, you can do so. You can get a couple free simulations, but do know that whatever you simulate on there is going to be publicly shared in the community. And then you can also schedule a product demo with maybe with myself or one of my colleagues and someone on my team. We can further discuss your situation and with our team of experts. So with that plug, I think I'll turn it back to the other presenters and maybe we can field some questions.
Very good. Thank you very much, Nolan. I really love seeing a live demonstration. There's no better proof than a product's robustness in a live demonstration. All right, welcome back to the webcast. Let's take a look at some of the questions. Why don't we just take some of the technical questions first and resolve them first, Nolan. First is a couple of people want to know what kind of mainstream major CAD formats can they work with in SimScale?
Yeah, and so we've worked really hard at SimScale to make our platform really CAD agnostic. So we have direct native import for many popular packages out there. I'm going to leave some out, I'm sure, if I start naming them, but tools like SolidWorks, Autodesk Inventor, NX, CATIA. But outside of those tools, we do have also a direct interface with the Onshape platform, which is another cloud tool for doing CAD. And we also support generic formats such as STEP or Parasolid.
All right. Somebody else also wants to know, how does cloud-based simulation licensing work? I guess it's very different from the traditional desktop node-locked model.
Yeah, it is. So we don't have any kind of licensed tokens or nothing is tied to your local hardware, and we don't have any kind of WAN structure or fees when you're out and about and you happen to be connecting from somewhere else on the planet. All we have is basically a paid subscription to SimScale, which gets you a login and access to our technology wherever you have a browser, and in a reasonably high-speed internet connection. We then have a pool of compute hours associated with a kind of our professional tier account, and those hours are going to be consumed as you go, and then they can always be re-upped at some point during the year as well if you happen to get to the bottom of your allotment. We have Teams licensing as well, so that can scale out to larger teams, and you can have multiple members logged in at the same time, collaborating on given projects, or even running different projects simultaneously. So we have a lot of flexibility in that regard, but nothing is going to be falling to traditional like node locked or floating licensing. None of those terms even really apply. It's
Okay.
very much login based. Yep.
One more question from quite possibly a beginner. How does one start with cloud-hosted simulation? What's a good place to start?
Yeah, I mean, the best place to start, as I mentioned, if you just go to simscale.com/signup, just to shamelessly plug it. But if you want to dive in and see it for yourself, you can create what we call our community account on there, and that gives you access to some of our flow solvers, some of our structural solvers, and there's a limit on, I think it's 10 simulations you can do. But that would give you a little exposure to just how easy it is to set up and run your simulations on the cloud.
Okay, all right. This question, I think it's about the hardware's effect on the software's performance. So let's take a look at that. What components in your computer, for example, GPU, memory type, and quantity of RAM on the graphics card? What type of CPU, how much core is needed, how many cores? In general, how does the hardware in your local computer affect the performance?
Yeah, so in general, we're not very taxing on the local hardware. You obviously need to have a computer with reasonable 3D graphics capabilities. I would say integrated graphics are just fine. And probably really any computer built in the last 10 or 15 years would be adequate enough. If you're unsure if the particular hardware you have is going to be up to the task, you can go to simscale.com/check, and that will run a really quick diagnostic check that will actually let you know whether your machine and internet connection is suitable for SimScale. Yeah, and really the heavy lifting again is done via our cloud provider. So things like meshing and solving the large systems of equations, that none of that is being carried out on your local machine.
All right, good. One more question here. I'd like to ask if SimScale provides free computer core hours for researchers for submitting a paper in the journal. What are the additional costs? Could you address that?
Yeah, we do have an academic licensing scheme that sounds like it would fall under that heading. So I would definitely reach out to either through our website or sales@simscale.com, and you can get connected with our academic account manager, and we do have some different pricing schemes in mind with that. So that'd be my suggestion to you. Happy to always help out a student or researcher.
Yes. By the way, this is not a question from the audience, but I just thought about it when I was watching your demonstration. When people are signing up for cloud, choosing the kind of virtual machine that they'll spin up, I'm sure they have the choice to choose CPU and GPU as well, or a mix of it. Are there specific type of simulation that works better on the CPU or the GPU? Could you give some guideline on that?
Yeah, in general, most of the approaches we use in SimScale are solved via CPUs a little bit more traditionally. However, we have some newer tools, such as our Lattice Boltzmann solver, which is utilized for aerodynamics and heavily used for city level pedestrian wind comfort. That actually does run on GPU instances as well. And the user doesn't have to pick or choose or configure it. It's just that those are going to be running on GPUs instead of CPUs. And that methodology is vastly parallelizable. So it's going to be a very, very fast way to run transient aerodynamic studies.
All right, very good. One more question about composite materials. Are there plans to introduce composite materials? I guess as part of the choices of material you have, you can simulate.
Yeah, so I didn't really touch a whole lot on our finite element analysis capabilities. Excuse me, but we're currently in the process of introducing composite materials. That will be something it's currently under development. So as it stands right now, SimScale does not support composite materials, but that's certainly something on our roadmap.
All right. One more question here. How is the automated meshing rendered? Is it generally hexahedral, hexahedral based? Is the term
Yeah, so,
correct?
yeah, and meshing is a big topic. We have a couple of different approaches depending on the type of physics you're looking at. So I would say we have an automated approach that is going to be using a combination of tetrahedral cells and things like prism layers to capture the near wall boundary layer effects. It transitions to a hexagonal core away from the walls or away from surfaces. We also have a snapped hex dominant mesher as well, again for CFD studies. And then for the FEA side of things, we have a tetrahedral mesher, and we support mid-side noded elements. So say a TET 10 element, second order accurate with that type of approach as well. So we keep working different meshers into the tool for specialty edge cases as well, things like sweep meshing to make things more efficient. So best bet is to dive in there and start working through some examples to get a feel for really how we approach automated meshing and all the controls you have over it.
All right, very good. Audience, by the way, with the time allotted here, we may still have time for about 4, 5 more questions. If they're technical, maybe we spend more time on that. So if you have questions, good time. You still can type them in, submit them while Nolan is still online with us. Let's take one more. Is SimScale capable of running a SimScale run study with multiple specimens, for example, argon, nitrogen, etc.?
Currently, we don't support multiple gas species, but we do commonly use things like passive scalars to track the motion or to track the introduction of a contaminant or a minor species that may behave very similarly to the bulk flow or to the bulk species. So something like smoke or carbon monoxide in a room, or maybe mixing very similar liquids. But we do not currently have multi-species or any kind of chemistry modeling.
All right, here's one more question. This one, apparently, because of the popularity of the emerging generative design or topology optimization trends, does SimScale do optimization, generative design, or topology optimization?
We do not, and that's but that's an interesting field of study. It's certainly something I'm very interested in. I have a bit of a background in additive manufacturing as well, which is typically needed to make a lot of those really interesting, wild shapes. What I would say is SimScale can definitely be used to validate generative designs, maybe produced in an external tool, but then actually seeing how they behave maybe under the loading conditions you may see. So maybe the as-built parts, you're maybe doing your final validation in a tool like SimScale, but it's not. We're not given a design space and loads and frozen areas and giving you an optimized shape. That's not something we currently are doing.
All right. Nolan, I want to give you a chance to also take a look at scan the new questions that came in and rate them for us for which one you'd like to address them live right now. And in the meantime, while Nolan is scanning the questions, I just want to tell you about a fun little exercise where SimScale participated. And that was actually in one of the latest articles that we did call "How Would You Redesign the Star Wars TIE Fighter?" So it's where I wrote the article. I asked a number of CFD experts, CFD technologists to help me run CFD exercises on the TIE Fighter and see if it is indeed aerodynamically optimized, and if not, what are the ways in which you might want to reshape the geometry. It's a fun article to look at. Take a look at. It's an article that prompts a lot of discussion, interesting discussions about the nature of CFD in space. So Nolan, you have identified one more question. Let's go ahead and see if we can address that. For maximizing the simulation, is it better to use a Mac computer?
Yeah, that the type of computer your local machine is completely irrelevant, honestly. We have users here at SimScale that use PCs, Linux, and Macs. I think our really only one of our main recommendations is we develop on Google Chrome, or that's where we do most of our QA. So that's generally a recommendation, but I've seen users use different web browsers and have success as well. But no, the Mac versus PC, that should not make any difference to SimScale.
All right, one more question. This is about data security. It's a fair question. It tends to come up with cloud discussions. How secure is my data? Can I download it onto my local machine when I'm done, wipe it out from the cloud? And how long can I maintain my account after expiration?
Okay, so how secure is your data? We have some great content on that. That's a pretty big question, but we have some information basically detailing how we handle data and how our cloud partner, AWS, secures and handles their data as well. It's our cloud partners, they're the same that are probably managing a lot of our banking information and things like that. So we put a lot of trust in that, but it's certainly understandable. So we have some content on that on our site, and maybe that's a discussion we could probably have offline. As far as downloading it to your local machine, yes, you can download all the results from our all of our solvers. So you can bring in a local copy of your results for further post processing, or maybe some level of automation, or doing something else with it. And you can wipe your account from the cloud as well. You can actually even request. I think we have a formalized process as well to ensure if you want to make sure your data is fully eliminated. And then your account after expiration, you still would have view privileges to your results and runs you completed. So you're not locked out from that. You just wouldn't be able to run any additional new simulations.
All right, very good. Unless there are more questions coming in from the audience, this may very well be the last batch of questions. We'll give it a few minutes, but in the meantime, Nolan, based on the questions that we receive, do you feel like is there something else that may be worth clarifying, or maybe something that you might like to share as parting thoughts for the audience?
Yeah, I mean, I'm seeing a lot of interest in structural mechanics, and I know I didn't cover that. And truth be told, my first love, let's say, my main strength and background is in CFD and aerodynamics. But I would say to all of the FEA and structural mechanics folks out there that it would be really helpful, I think, for you to just jump in and start simulating with the community account, even if it's just doing a tutorial problem to get a feel for our approach to structural mechanics and kind of the breadth of what's there. But I am seeing a lot of good questions, and it's encouraging. And I just want to kind of remind everybody that, I showed a lot of flow-oriented pictures, maybe just due to my specific background. We have, a wide feature set involving, nonlinear FEA as well. So I don't want those folks to feel slighted or left out. A couple of new questions came in here too.
Yeah, take a look at some of the new questions, and if there are a couple of them that may be beneficiary for all the audience, if we can address them live, so to speak. Otherwise, I'm sure you'll be able to get back to them individually as well. So, yeah.
Okay.
There are, of course, a lot of questions about file formats. Understandable, because a lot of people want to be able to download their data or use the output from SimScale in another simulation program, for maybe because they're thinking about the next level coupling with something else. So what are your thoughts?
Yeah, in general, I mean, the format that you're going to be downloading is going to be something more consistent with being able to open it in post processors. On the structural mechanics side, kind of in the background, we're running CodeAster, maybe a tool that some of you are familiar with. So we're going to be exporting results to something that would, say, be compatible with a tool like maybe ParaView or one of those other post processors out there. And as far as the viability of bringing that into a different structural mechanics tool, I'm not really well versed or sure of that. As far as the translation, there may be like an intermediary step needed there. But in general, we would prefer that you're going to be, doing the modeling in SimScale and taking advantage of the cloud capabilities we have,
Sure.
and then maybe doing maybe more automated post processing or something like that if you choose locally. So it's more of a post processing, not a pre-processor.
All right. Maybe we can take this as the last question before we wrap up. Here is can multi-phase fluids be modeled? So, Nolan, perhaps also for the beginners who might not be familiar with it, could you give us an example of the kind of phenomenon where multi-phase fluid
Yeah,
happens?
yeah, great question. Is that Gary? Yeah, the multi-phase can be modeled in SimScale, and we're actually making some really big strides to make that even faster and more robust, because it is a pretty heavyweight simulation. Multi-phase is when you have two dissimilar phases of matter, all participating uh, in one system. So something like pouring water into or out of a cup, maybe a dam breaking, or anything, a toilet flushing. Those are all examples of multi-phase flow, and we can do that today, and it's going to be getting even better in the weeks to come here. So that's something you can certainly look into using SimScale.
All right. I think this question, the last one, maybe we can squeeze in this one. This is important. Do you have a data storage limit for cloud simulation?
Easy one. No, no limits.
Okay, okay, very good. All right. With that, I think we have exhausted all the questions that we can take, and then there are some questions that obviously will take a lot more detailed answers. So for those, Nolan is going to work with his team to get back to you. Nolan, do you have any last minute thing you want to say before I close it up?
No, I appreciate everyone's time and attention wherever you are in the world today, and I hope everybody learned something. And I'm really eager to see a bunch of new action on the SimScale community accounts. So yeah, thanks again. Thank you, Kenneth, as well, and the folks at Digital Engineering.
My pleasure. Thank you very much, audience, for spending your precious afternoon and your precious time with us. I'd like to thank our presenter, Nolan. I'd also like to thank SimScale for making this live discussion possible, for sponsoring this, and also want to thank our webcast producer, Steve Paul, who is invisible but who makes both of us look good and sound good, so that you can get the best experience, audience. So until next time. I'm Kenneth Wong with another successful episode of DE Webcast, and we are signing out.
Thank you.